Hi everyone, we're going to go through a summary of Chapter 8. I've got a few questions here that should cover everything that will be on your quiz for Chapter 8 and hopefully explain anything that you may have been confused about in this chapter. Question number 1, suppose the local sales tax rate is 5%. You purchase a car for $11,800. How much tax is paid? All you need to do on a question like this is just sales tax, so it's just a flat tax rate. You're going to multiply the total cost of the car by the 5%, so 11,800 times 0.05, and that gives you $590. So the total cost is the cost of the car plus the amount of tax, so 12,390. That one's pretty straightforward. This type of question, oh, and you should print out, I've posted this PDF in the course. You should see it in both the announcements and I'm going to add it under course content. So find the PDF in one of those two places and go ahead and print it out so that you can follow along more easily. In number 2, we've got to calculate the income tax owed by a single male with no dependents. So since this person is single, we know we're going to be looking at the single column. Here's his gross income, $83,000. He's got adjustments, $3,000, a list of deductions, and we want to find the income tax that he owes. The first thing we have to do is we have to start by finding his adjusted gross income. That is his gross income, which is $83,000 minus adjustments, $3,000. So his adjusted gross income is $80,000. Then to find his taxable income, we take his adjusted gross income and subtract both the exemptions and the deductions. Well, you can look up here to find the exemptions. It's listed in the chart. Since he's single, well, they're both $3,500, but he's got $3,500 in exemptions. And then for deductions, it's either one of two things. It's either the $5,450 here, or it could be higher if you do what's called itemizing and you add all of these together. If we add all of those together, 29,000 plus 4,454 plus 3,000, we get 36,454. That's definitely bigger than 5,450, so we're going to use that number instead as his deductions number. So we take his adjusted gross income, 80,000, and we subtract 3,500 for the exemptions and 36,454 for the deductions, and that gives us $40,046. So if you look in the chart and try to find where the $40,046 would fall, that falls into this category, which is the 25% tax rate. Now, unfortunately, it's not as simple as just multiplying 40,046 by 25%. No, instead, you need to first look at everything he makes up to $8,025 is taxed at 10%. So we have 10% times $8,025. Then everything he makes above $8,025 all the way up to $32,550, that's taxed at 15%. So if we take $32,550 and subtract $80.25, that gives us the amount of money that's in that 15% tax rate. So we multiply 15% times that amount. Then whatever's left over and above $32,550, that is what's taxed at 25%. So he had a $40,046 in taxable income, subtract $32,550 because we're now in this third category, and we multiply that by 25%. So using your calculator to do the multiplication, you get $802.50, $3,678.75, and then $1,874. Add those together, and you get a total of $6,355.25 as his income tax owed. Now, that may have gone sort of quickly for you, but remember, you can pause the video as much as you need to, and like I said, you should print out this PDF, which was posted in the announcements and in course content, and by printing it out, you can follow along a lot more quickly than if you're trying to write down everything yourself. Okay, number 3, this table shows data, one of the fastest growing U.S. jobs. Number of jobs in 2004 is 50, and the number of jobs in 2014 is 140. Well, percent increase is equal to the amount of increase divided by the original amount. So how much increase was there from 50 to 140? Just subtract. That's an increase of 90 jobs. And then according to the formula, we divide by the original amount, which was 50 jobs, so 90 divided by 50 is 1.8. Then convert 1.8 to a percent by moving the decimal 2 places to the right. That's 180%. Number 4, the principal P is borrowed at a simple interest rate for a period of time T. Find the simple interest owed. Assume there are 360 days in a year, and round the answers to the nearest cent. This is simple interest, so we're using the formula I equals PRT, interest equals principal times rate times time. Now, these formulas, there are several formulas in this chapter, some of them are very long. You're taking an online course, so you can have all the formulas right in front of you for the quiz, but you're probably wondering about the final exam. On the final exam, the formulas will be given on the exam itself. The exam is within iCollege, and when you have a question where a formula is needed, that formula will be right there for you. So you do not have to remember all these formulas. Okay, so if I equals PRT, the principal is 6,000, so that's P. The rate is 8%, 0.08, and the time is 6 months. How many months are in a year? 12. And remember, T is time in years. So if we're talking about a year, this 6 months is 6 months out of 12 months. So 6,000 times 0.08, and 6/12 reduces to 1/2, and that's 240. So $240 in interest. Principal is borrowed and the loan's future value at time T is given. Determine the loan's simple interest rate to the nearest tenth of a percent. This is the formula when you're trying to determine a loan's future value if you're talking about simple interest. So we're just going to fill this in. A is given as 4,300. P is given as 4,000. And then 1 plus R times T. T is 1 because it's 1 year. So we have here you have R times 1 is just R. Then you need to distribute. So when you're distributing here, let me get 4,000 times 1 is 4,000, and 4,000 times R is 4,000 R. Then you subtract 4,000 from both sides, and you're left with 300 equals 4,000 R. So you divide both sides by 4,000. So 300 divided by 4,000 to get R. And 300 divided by 4,000 is, you just do this on your calculator, 0.075. So 0.075 is, I can be a little neater, 0.075, when you convert it to a percent, is, of course, you move the decimal 2 places to the right, and 7.5% is your answer. Okay, you borrow $8,000 on a 6% discounted loan for a period of 3 months. So this is simple interest again, so we're using the I equals PRT. You're determining the loan's discount, which is just the amount of interest that you're deducting. So I equals PRT, you've got a principal of $8,000, an interest rate of 6%, so 0.06, and it's 3 months, so 3 out of 12, because remember time is done in terms of years, 3 months out of 12 months. So when you multiply, and I've got a screenshot of what I typed into the calculator over here, 8,000 times 0.06 times 3 out of 12, you get 120. So really, when you're asked for the loan's discount, you're just finding the interest, so $120. So the net amount of money you actually receive, they're going to deduct that quote-unquote loan's discount from this amount of money that you've borrowed. So 8,000 subtract 120, you'll actually receive $7,880. The loan's actual interest rate. Okay, what is the loan's actual interest rate? We're going to use I equals PRT to determine that. So 120 is the interest, 7,880 is your actual principal, R is what we're trying to figure out, the rate, and 3 out of 12 is the time, 3 months out of 12 months. So when you multiply 7,880 times 3/12, you get 1,970. Divide both sides by 1,970, and again over here is a screenshot of what you see in the calculator. So it comes out to 0.060913 and so on, but it said to round to the nearest tenth, so this 0 rounds up to a 1 because of the 9 that comes after it, so 6.1%. Number 7, in order to start a small business, a student takes out a simple interest loan. So simple interest is the key. We know we're going to use I equals PRT. How much interest must the student pay? $2,000 is the principal. That's the loan amount. 7%, that's the rate, 7%, 0.07. And 3 months, 3 out of 12, because there are 12 months in a year. Multiply that, you get 35. Here's a screenshot from the calculator. The future value is the principal plus the interest. So the principal was 2,000, the interest was 35, so the future value is 2,035. Number 8, the principal represents an amount of money deposited into a savings account subject to compound interest. So there's a keyword, compound interest. You know you need to use this formula that I've put over here to the side. So we're filling that in. P is the principal, 7,500, and then it's 1 plus R over N. R is the interest rate, 3.5%, so 0.035, over N. N is the number of times per year it's compounded. If it's compounded monthly, that means it's compounded 12 times per year. So N is 12. That is then raised to the power of N times T. N is 12, T is 4 because the time is 4 years. So how do you enter that into a calculator? You don't want to enter it, piece by piece by piece, because then you're going to find yourself rounding off a lot, and that's going to mess up your final answer. To enter all of this into the calculator at once, I've included a screenshot here to show you how you would enter that. Now, the only thing that I slightly changed was I went ahead and instead of typing 12 times 4 here, I typed 48 because I know 12 times 4 is 48. So that's how you type it into the calculator, 7,500 times 1 plus. You always want to put fractions in their own set of parentheses. So the 0.035 over 12, I put that in its own set of parentheses. Then I needed another parentheses to close that quantity out. and then raised to the 48th power. The reason that you need the 1 plus that fraction in parentheses is because that is what you're raising to the 48th power. You don't want the calculator to think that you're only raising this part to the 48th power, and you don't want the calculator to think that you're raising this to the 48th power. You want the calculator to know that it's only that second part, that part in parentheses, that's being raised to the 48th power. So you get $8,625, and that 5 here makes the 29 round up to 30. So that gives you your answer. So what's the amount of interest earned? Take that number, the total amount, and subtract the original amount you invested, which was $7,500. By subtracting that, you get $1,125.30. So that's how much interest was earned. And again, if I'm going through this too quickly, pause, rewind, go back, make sure you've got this printed out, make sure you're working through this yourself on your own calculator as we go through it. That's going to be the only way for you to make sure you know what's going on. Number 9, you have $15,000 to invest, and which of the two rates would yield the larger amount in a year? So one is you've got continuously compounded, and one is you've got compounded daily. Okay, continuous, I should have put these, I kind of put these backwards, but that's the continuously compounded formula. So if we want to know how much we're going to earn at 5.8% compounded continuously, we've got the principal P times e to the r, which is 5.85%, 0.585 times 1 t, time in years, 1 year, and then throw that into the calculator right here. And so that gives you $15,903.67. Then when we do compounded daily, we're talking about this formula, and we've got P, which is 15,000, times 1 plus, the rate is 6%, so 0.06, over 365. Okay, it's compounded daily, so there are 365 days in a year, so n is the number of times it's compounded in a year, to the power of n times t, so 365 times 1 because it's 1 year. And then here's a screenshot of how to enter it into the calculator all at once. And again, I've got this in its own set of parentheses. And that yields $15,927.47. It would round up to 47 cents because of that 9. So when you compare those two results, you can definitely see that this one is the larger amount of money. So doing the compounded daily would give you the larger amount of money, so that's the one you'd want to choose. Okay. Number 10, how much money should be deposited into an account that earns 4% compounded semi-annually, that means twice per year, so that it will accumulate $12,000 in 3 years. This is the formula when you're trying to figure out how much money you need to deposit or you need to invest in order to make sure that you have a certain amount later. And when it is compounded interest and not simple interest. So we just basically fill that in. And here's a screenshot of me filling in that formula. P is 12,000. Sorry, not P, A. I'm just filling this in. A is 12,000 because that's how much we want it to be worth, divided by 1 plus 0.04 is the rate, R, divided by 2, N is 2 because it's compounded semi-annually, to the power of n times t. N is 2, t is 3 because it's 3 years. And the calculator just gives us our answer. And that 5 rounds up to a 6 because of the 6 that comes after it. So $10,655.66. Number 11, at the time of her grandson's birth, the grandmother deposits $5,000 in an account that pays 4% compounded monthly. What will be the value of the account after the child's 21st birthday? Okay, so here's our formula when we've got compounded interest. We know the principal, and we want to find out how much it will be worth after a certain amount of time. So here's a screenshot where I have filled in the value of P, which is 5,000 because that's how much she deposited, times 1 plus R divided by N. The rate is 4%. N is the number of times it's compounded per year, and it's compounded monthly. There are 12 months in a year. To the power of 12 times 21. 12 is N, 21 is the number of years. So where did I get that T is 21? Well, it said at the time of his birth, and now they want to know what will be the value when the child is at his 21st birthday. So it will have been 21 years. And then the calculator just gives us our answer, $11,565.67. That 6 rounds up because of the third number being a 7. Number 12. In these types of problems, the formulas are just, they're so large that they're just given to you within the question itself, just like it will be on the final. So here's our formula that we're using to try to determine the periodic deposit. And in this case, it's how much do we want to deposit at the end of each month. Gives us a rate of 4%. It's compounded monthly. So since it's compounded monthly, N will equal 12 for 18 years. So T will be 18. And our financial goal, how much we want to have at the end of the 18 years, is $260,000. So the goal, or how much the future value, that's always A. So here are some screenshots of me filling this in. Now, I did do this 2 pieces at a time. I did the numerator, A times R over N, so 260,000 times 0.04 over 12. So that's my numerator. And then down here I did the denominator, 1 plus R over N to the power of N times T minus 1. So my denominator, this whole thing, came out to be 1.05197 ... So then I took those two numbers and I did 866.66666 divided by 1.05197, etc., to get my final answer, which they said to round to the nearest dollar. So $823.84. Since this is bigger than 50 cents, that's going to round up to $824. And then part B, how much of the financial goal comes from deposits and how much comes from interest? Well, take the number of deposits that you're going to make, multiply that by 18 years, and you're making a deposit every month, so multiply that by 12 months in a year. So monthly deposit times 18 years times 12 months in a year. That means we only actually deposited $177,984, and our total goal, or what we're going to have, is $260,000. So if we subtract that $177,984, we'll know how much of that money is actually coming from interest, and what's coming from interest is $82,016. Okay. Number 13, again, you're given these formulas to fill in the question itself, and you have to choose which one you're going to use based on whether it's simple interest or compound interest. Now this is saying that it's being compounded monthly, so we need to use this formula rather than the first one because we've got compounded and not simple interest. So we've got to have those n values in there, the number of times it's compounded. So here in part A, I'm just showing you exactly what I type in order to fill in this formula. The principal is $40 because it gives you this in the question. You're depositing $40 at the end of each month, times 1 plus R over N. The rate is 0.065. N is 12 because it's compounded monthly, to the power of N times T. How did I get T is equal to 36? Well, that's because we're retiring at age 65, and we started this thing when we were 29. So that's 36 years later. Then minus 1, and then divide all of that by R over N, which is 0.065 divided by 12. So by filling all those numbers into the formula that was given, I get $68,794.25, but the instructions say to round to the nearest dollar, so $68,794. And then part B, the interest, how much is the interest? Well, that's the amount we have, but if you subtract all of the deposits that we made, we deposited $40 a month, 12 months in a year for 36 years. So a payment of $40 times 12 months per year times 36 years, if we subtract that from the total amount that we're going to have, we're left with $51,514. That's how much interest we made. The price of a condo is $183,000. The bank requires a 5% down payment. The cost is financed with a 30-year mortgage at 8%. Okay, down payment, that's a very straightforward, just a flat rate. You're multiplying the price times 5% to get a down payment of $9,150. That means the amount of the mortgage, you subtract the amount of the down payment from that. That gives you the amount of the mortgage. How much must be paid for the 1 point at closing? So to figure that out, you just multiply the amount of the mortgage. Now that we've subtracted the down payment, 1 point really just means 1%, so multiply it by 0.01, and you get $1,738.50, but it says to round it to the nearest dollar, so that rounds to $1,739. Find the monthly payment, excluding escrow tax. To do that, we use this PMT formula, and I'm just going to fill that in. We're making monthly payments, so N is 12, and you can see here that I'm just filling that in. And what I did was kind of what I did a minute ago. I found the numerator, P times R over N, and then I found the denominator, 1 minus 1 plus r over n to the power negative n times t. So be sure to put that negative sign in there. Don't forget that. That's going to change your answer significantly if you don't. And then, let's see, I took the numerator that I found, 1159, and I divided it by what I got here, this 0.908. You may or may not already know that your calculator stores the most recent answer as ANS in your calculator. So this 0.9085566,276, there's no need for me to retype all of that because I can just go to my calculator and I can say second and then right above this negative sign ANS. By using that, I don't have to retype the 0.098555. I can just say 1159 divided by answer. And the calculator knows that answer means this most recent answer that I got. So now by dividing those, I get my final answer, which is my monthly payment, $1,275.649, but it says round to the nearest dollar, so that's $1,276. Find the total cost of interest over 30 years. Okay, the total cost of interest over 30 years. So over here we have part E, 1276 times 12 times 30. That is where I'm trying to figure out how much I've paid from my monthly payments. My monthly payment is $1,276 times 12 months in a year times 30 years. That gives me $459,360. So from that, I need to subtract the original amount of the mortgage, $173,850. That means over the life of this mortgage, I've paid $285,510 in interest. So that kind of shows how much it does help to pay extra on your monthly payment. You get finished a lot sooner and you don't pay as much interest over the life of the loan. Now, I'm not going to talk through number 15 just because I actually, have everything typed up here. Every little detail is typed up in number 15. So if you have any questions about number 15, just shoot me an email because I've got every single detail typed up here. And remember, this is posted in the announcements, so just find it there and print it out and you can read over it. So good luck on your quiz, and I'll talk to you soon.